Welcome to the last part, which is going to be rational equations. This goes along with 10.4. Let's go ahead and just jump right in. So here's the steps to rational equations. We're still going to use the least common denominator. And what we're going to do is we're going to multiply the entire problem by the least common denominator. These are the three examples that I am going to be covering with you. So let's go ahead and take both of the numerators are already factored. Let's go ahead and take a look at the first denominator. The first denominator, I can take a 2 out. So this is become x minus 1 in parentheses. Over here, you have a difference of 2 squares. So this is going to be x minus 1 and, of course, x plus 1. So remember, when you go to find the least common denominator, you're going to write what the first denominator is. So I'm going to recopy the 2 and then the x minus 1. And then I'm going to take a look at the other denominator and write what I had not written already. I have already written this x minus 1. The only thing I've not written is the x plus 1. So this right here, that is going to be our least common denominator. And of course, this is just like you would do adding or subtracting of rational expressions. So you find the least common denominator the same way. All right, now let's go ahead and talk about restrictions. Restrictions for this, it's always a good practice to talk about restrictions. Restrictions are going to be x cannot equal a positive 1 or a negative 1. And I'll just go ahead and capture both of those numbers with that plus minus symbol. Okay, so now that we know what the LCD is, we are going to, again, multiply the whole entire problem by the LCD. So I'm going to recopy the original problem. And when I say original, it's not really original because instead of the binomial here, I am going to write it in factored form. So I am going to write the denominators in factored form. All right, so we're going to take both sides of the equation and we're going to multiply it by the least common denominator. That's going to wipe out the fraction bars. Remember, the least common denominator is here, so I'm going to multiply this left side. I'm going to multiply the right side. I have a little more room over here so I can write it regular where it's not slanted. And remember, just like when you were simplifying a rational expression, this is a whole number. It's kind of like over 1. And if I am multiplying this fraction by this fraction, remember whatever is on top can simplify if it has, or cancel or simplify if it has the same thing on the bottom. There's a 2 and here's a 2. So these two get to cancel out. Also, that binomial of x minus 1, that gets to cancel out. So the only thing that is left over here on the left side of the equal sign is going to be that single x plus 1, that binomial. And then I didn't have anything to cancel out that 5, so I'm going to multiply it by the 5. I'm going to recopy the equal sign. Now let's take a look at the left side. All right, so if you notice, I've got x plus 1 and x minus 1 down here in the denominator. Y'all have got x plus 1 and x minus 1 over here in the numerator. So the only thing that's left over here on this side is the 15 and the 2. So a little checkpoint for you. You know that you are solving these equations correctly if you wipe out the the denominators. Notice I drew orange lines with my orange pen through both of the denominators. Now I'm just left with just a baby junior high looking equation. Let's go ahead and solve it. I'm going to distribute. Of course, the side's a 30. Subtract 5 from both sides. And x is going to equal a 5. Now, before I box that in, I'm just going to glance up here and make sure neither one of these is a positive or a negative 1, and of course it's not. So that's going to be the answer to this problem. All right, here we go. Same steps. First thing we would do is, of course, factor the denominators, but the denominators are already factorable or in factored form. So the next thing we're going to do is we're going to identify what the LCD is. Remember, you copy the first one. You rewrite what you had not written already. So I'm going to now write down that x minus 7. That's the LCD. And the restrictions, x cannot equal a -4 or a +7. So remember, what we're going to do is we're going to multiply the whole entire problem by the LCD. So I'm going to recopy the original problem already in factored form. And remember, we take the left and the right side of the equal sign and we multiply it by the exact same thing. And we're multiplying it by the least common denominator. And again, the reason why we multiply by the least common denominator, it's going to wipe out those fraction bars altogether. All right, here we go. So I have an x plus 4 on the bottom. I have an x plus 4 on the top. These guys go away. Over here on the left side of this equation, on the left side of the equal sign, I am going to just have this x minus 7 and that single 6. I'm going to recopy the equal sign. Do the same thing on the other side. On the other side, guys, the x minus 7s cancel out. So that's going to be a 3 times the x plus 4. When we distribute, we're going to be able to solve this equation. Go ahead and get all of your x's on one side. I'm going to take the 3x from both sides, and I'm going to push the 42 over to the other side. So what we're going to get is we're going to get 3x equals a 42 plus a 12 is a 54. And then we're going to, of course, divide. So x is going to equal, yes, it's so fun to do that stuff in your head. So if there was any levels to what we were doing today, the first two examples were kind of level 1. This, you would level up a little bit, and I'll show you why. So factor it out. This one's already in factored form. So the LCD is going to be 5x plus 2. And guys, remember, that's a binomial. So when I go over here and I see this single x, I have not already written that. In fact, I need to put parentheses around that. So I have not written a single x, so I still do need to write that down for it to be the least common denominator. All right, here we go. We're going to multiply this whole entire equation by the LCD. I'm just going to copy the original. Let's go ahead and multiply both sides by the LCD. And then 5x plus 2, 5x plus 2. X times 3x, y'all, is 3x squared. Recopy your equal sign. This single x cancels out that single x, so the only thing that's left over here on the right side is just going to be 5x plus 2. So this is not like a junior high level equation. This is actually an algebra 1 level equation. Remember, when you have x squared, everything gets pushed over to one side of the equal sign. In other words, we're setting it equal to 0. So let me scoot up just a tad. So we're going to have 3x squared minus 5x minus 2 equals 0. So let's see if this quadratic is factorable. 3 times the -2 is going to be a -6. Middle number in the top of my organized work here looks like that's factorable because we can do a -6 and a +1. So here we go. I'm going to recopy the first term. Instead of writing that -5x, I am going to add these two. So a -6x and a positive single x is going to be that -5x. I'm going to recopy the last term. And now, of course, I'm going to factor by grouping. I love factoring by grouping because if I get matching factors, that is a checkpoint that I have factored correctly. So here I get to take out a 3x. So that's going to leave x minus 2. And that is exactly what that is. But remember, you have to factor out something every time. If that matches exactly, all I can factor out is a +1. So our factors are going to be 3x plus 1. And then, of course, it is going to be x minus 2. And remember, to solve for the x's, you set each one of them equal to 0 and solve. When you set that equal to 0 and solve, you get a negative 1/3. When you set that one equal to 0 and solve, of course, you get a 2. And again, before I box that in, I'm going to come up here and just kind of glance at my LCD and make sure that it wasn't a restriction. And it wasn't, because the restrictions would have been a negative 2/5. And then, of course, just a single 0. So I get to come down here and then just go ahead and box in my final answer.